today we are talking about transformations of parent functions. Today, more specifically, these are rigid transformations. And all of these today you can do and you can check on your calculator. These are all functions that you could graph on your calculator. But of course, I'm never going to ask you that on test because I know you have a graphing calculator and can do that. So the object is to know how these transformations work so that you can apply it to a generic function, so a picture of a function instead, okay? And we'll be doing those the day after tomorrow. Today, we're talking about rigid transformations, meaning they are rigid and the shape of the function does not change. So it doesn't stretch or shrink. It stays exactly the same, and all the function is going to do is slide left, right, up, or down. And what we want to be able to do is learn a little bit of notation and some very simple steps. So these are all based on our parent functions that we talked about yesterday, graphs that you should know. So number one, y equals the absolute value of x. This is our parent function. What shape is our parent function? A v, absolute value v. Bless you. And if you'll remember from yesterday, that parent graph started at 0, 0 and goes to the points 1, 1 and negative 1, 1. And so this is our first graph, our absolute value v.
So hard to see on this.
Yeah, I'm sorry for the copies. They didn't come out as dark as I hoped. So I want to introduce you to a little bit of function notation. We have a generic function instead of like absolute value, and the way we would write that is y equals some function f of x. And what that means is some function, and you can see here our function was actually the absolute value function. But generically, we can use any letter we want. So you'll see how that happens on Friday. Now, what's the difference here on number 2? It shifts. Yeah, we've got a transformation in there. We have a value. Would you call that value, would you say it's on the inside of the function or the outside? Yeah. Inside. Yeah, sure. It's inside the absolute value. It's inside the function. And more importantly, it is inside with x. And what that means is it's going to shift our graph in the x direction. So a transformation like this always shifts in the x direction. And it shifts like this. F of x minus c is how we would write that using generic notation. The c is some sort of constant. You'll notice that it's f of x minus c, meaning that it's the opposite of what it sort of appears. So x minus 3 shifts the graph which direction? Right. 3 units. All right. And all I have to do then is take my points and count right 3. Nothing else about the shape changes. It just slides to the right 3 units. All right. Number 3 there, we have a 5 included, at negative 5. Is that, would you call that value on the inside of the function or the outside of the function? The outside of the function. That is on the outside. When values are on the outside of the function, it affects the y values of our graph. So the y-axis goes up and down, so things that are on the outside cause a vertical shift. So vertically up or down. So when we see something on the outside, such as y equals f of x plus c, that's going to be a vertical shift. Let me write that down. Vertical shift. When the c is on the inside, it's a horizontal shift. Okay. So what is that minus 5 going to do to our graph? It goes down 5. You'll notice it's a plus C, and that's actually going to do exactly what it says it's going to do. Down 5 makes sense. Everything with X is always sort of inverted, opposite. So I'm going to take my original absolute value function, and I'm going to shift it down 5. And that is graph number 3. Now we have one more transformation we're talking about today, and that is here. With a negative, I'm going to rewrite that as y equals negative 1 times the absolute value of x. Would you say that negative 1 is on the inside or the outside of the function? Outside. And it's on the outside, which is going to affect the y values. I'm going to write that as y equals negative 1 times my function, whatever function I have. What that's doing, since it's affecting the y values, it's actually turning them to the opposite. We're going to be multiplying those y values by a negative, which is going to make them change something. And so what that causes, you can imagine here on our regular graph, my original absolute value graph had a y value at positive 1, but if I multiply it by a negative, it's going to flip and become negative 1. And so we call this a vertical, I call it a vertical reflection. A vertical reflection meaning it's reflecting vertically up and down, so it gets shifted or flipped. Some teachers call it a vertical flip or a reflection, just a reflection. I think your book says that it's a reflection across the x-axis, which to me seems confusing because the y values are changing, but it's reflecting over the x-axis. It is reflecting over the x-axis, but that's what the y values are changing.
Does that line go on top of the other line?
Which line are you talking about?
Your green line goes on top of your 1.
So it's the 0, 0 doesn't change. So that one just stays there. But no, they're two different graphs.
Oh, it's going that way.
Yeah, so my absolute value function got flipped over. Yeah. All right, let's try a few more. Those are the 3 transformations we're dealing with today.
Bless you.
Thanks.
All right. Fluticasone is your friend. Okay. Number 5. What shape is number 5? Parabola. And what I want to make sure is that you do not draw a V. So I like to include a second set of points, 2, 4, and negative 2, 4. Your parabola should be a nice, smooth curve. It should not have any sharp points on it. Okay, so make sure it's a nice, smooth curve. That is our base function, our parent graph. I'm going to give that a number 5. All right. Now, on number 6, we have a constant. Is that constant in the inside or the outside of the function? Inside. Does that affect x values or y values? X values is inside with the x. So that's going to move in the x direction. It's going to move to the left and right. How should it move? It is left 5. It is left 5. Let me talk about why. You guys didn't answer fast enough, so I think you're wondering why. In my notation up here, it's f of x minus c, minus a number. So if I were to write this so that it used subtraction, to get a positive, we would have to subtract a negative 5. Okay, minus a negative 5. So this says our C value is negative 5. That means we're going to negative 5. What? This? Left? Left 5.
Oh, I thought it was 6.
All right, so the negative 5, we are starting where x is negative 5. It moves left 5 units. It's always sort of opposite what it appears. And if you can understand that today, then tomorrow goes a lot better. Everything with x is inverted, always. All right, so that gets shifted. Left 5 units. All right, on number 7, how many transformations are there? 2 transformations. What does that x minus 3 do to the graph? Right 3 units, good. And what about the 4? Up 4, yeah. Everything with the y's is just what it says. So we're going to take our blue graph and we're going to shift it right 3 units and up 4 units. Right 1, 2, 3, up 1, 2, 3, 4. Right 3, up 4. So when we have multiple transformations, order is very important. The order that we graph those transformations makes a difference. And so you'll notice on this first one, we did the right 3 first, and then we shifted up 4. I would say like 70% of the time it doesn't matter. But of course, I'm going to do it the one time that it really does matter. That'd be what I would test you on. So in general, when we're figuring out the order of the transformations, we want to observe order of operations. Order of operations says we need to work inside the parentheses first, right? And so we want to start inside working with the x values, and then we'll work our way out from there, which is why we started here with inside with x and then did the outer function. All right, so same thing here. We have 2 transformations. Which one should we look at first?
The negative.
The x minus 4, and how's that going to shift our function? Right 4, good. And then what does my negative do? Vertical reflection. Yeah, vertical reflection. So I am going to do that. I'm going to take my original parent function and I'm going to shift it right 4 units. 1, 2, 3, 4. I'm just going to put some marker dots there. You can imagine there it is. There's my function shifted right 4 units. But now I also need a vertical reflection. So my positive y values are going to flip. Positive 1 becomes negative 1. Positive 1 becomes negative 1. So my parabola flips upside down. Okay? And that was number 8. Okay? Questions so far? Hopefully you've done these before. And again, if there's one that seems tricky, you can use your calculator on these to double check. Make sure you did them right. All right, ladies and gentlemen, number 9. What is the shape of our parent function? Swoop. Swoop. You'll notice the shape of the square root swoop is almost the same as the shape of the root radical. All right. So number 9 there is our square root swoop. Number 10, what transformations do we have to our base function? Which one do we do first? Inside, yeah, inside with x. We got to do that first. So what does x minus 4 do to the function? Left 4 units. And then we're going to count down 5. So I'm going to take my points and just count left 4, 1, 2, 3, 4, and then down 5.
Miss, what is that at?
-5. Oh, the y-intercept?
Yeah.
The y-intercept is at -3. All right, number 11. What happens on number 11? Vertical reflection. Vertical reflection. So again, my value here that's at +1 is going to flip and become -1. And +2 is going to flip and become -2. Does 0, 0 flip? Sure. But it doesn't move anywhere. Still stays at 0, 0. 11. All right, ladies and gentlemen, number 12. Number 12 is very, very tricky. Number 12 is very, very tricky. How many transformations do we have with number 12? 3 transformations, and this one order is essential because if you don't follow the proper order, you will graph a very different picture. So one like this where there's 3 transformations, I really encourage you to do it by hand first and then double check using your calculator. Just make sure you put proper parentheses in and stuff when you use your calculator. So we have 3 transformations. Which one do you want to do first?
Left to right.
Left to right, good. On the inside, how are we going to shift horizontally?
Right 3.
Right 3 units, good. And so now the question is, we have a +2. We also have a multiply by -1. Which one do you think we're going to do first?
+2. I'd say the up 2.
You reflect it first.
Because
So the question is, why would we worry about that multiply by -1 first? PEMDAS, order of operations. We must multiply before we do any adding or subtracting. Okay? So the next thing we're going to do is our little vertical reflection. And then the very last thing we're going to do is shift our graph up 2 units. Okay? Order matters. And if you don't do it in proper order, you're going to get a very different shaped graph. So I'm going to start with my blue base function here. It's going to shift to the right 3 units. 1, 2, 3. So I'm going to just sketch in those points. So just like this. So there's that first transformation, just sliding it to the right 3. Now the second transformation is a vertical reflection. So it's going to, here my +1 is going to flip to a -1, and +2 flips to a -2. So now my square root swoop is upside down, reflected vertically. So it's this half. And then I have to take those 3 points and shift them up 2, up 2, up 2, and up 2. Oh, this one should be here. All right, we're gonna try another one of those, so don't freak out.
Oh, it's just one couple
4, 1. The starting point is right here at 3, 2. So that's 3, 2, 4, 1, and yeah, I think 7, 0 maybe, or 8, 0. I'm not sure. Ran out of graph space. That's good. All right, last set. And if you're finished, then feel free to start on homework. Y equals x cubed. What is the shape of that function? A sort of a squiggle. Yeah. Looks like a water slide I went down this summer.
Well, baby.
What I like to remember about these 3 points are great, but the shape of this function is not a straight line. So we want to make sure that it curves and is quite tall. Alrighty. Number 14, x minus 3 quantity cubed. How does that shift our function? Right 3 units. Right 3 units. 1, 2, 3. And again, you can always check on your calculator. Number 15. What happens on number 15? Vertical reflection. Vertical reflection of my original function always. So my positive 1 flips to a negative 1, and my negative 1 also becomes the opposite and flips to a positive 1. All right, and then the very last one. How many transformations on number 16? Again, this is very tricky because there are 3 transformations. We want to make sure that we do them in the proper order. What do we do first? Yeah, the x plus 4 shifts it how? Left 4 units. Very good. And then what do we do? Now the vertical reflection. We have to multiply first. So we're going to do the vertical reflection. And then what's last? And then our down 4. All of that happens from our base function. So we're going to shift to the left 4. So I'm going to take my dots and go 1, 2, 3, 4 to the left and make those little marks there. So this would be that first transformation. And then what happens? It got a vertical flip. So it flips around and now it looks like this. And then it has to shift down 4. So I take that last point and go down 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4. And there is our number 16.
Whoa.
All right, ladies and gentlemen. Now the rest of you to finish the other side.